Hi everyone, Melissa Wilson here. I'm your friendly land application specialist at the University of Minnesota. Today we're going to talk about calculating application rates for your composted manure. So first up, let's talk about the why. Why does it matter how much composted manure we apply? Well, there's two reasons. The first is that plants need a minimum amount of nutrients, and if you don't give them these nutrients, then they're not going to thrive. But on the other hand, too much of a nutrient can be a bad thing. Some of these nutrients, when they become in excessive levels in the environment, actually end up causing problems. One of the things I want to highlight here is some of the nutrients I'm going to be talking about, and those involve nitrogen, which is denoted by the symbol N, phosphorus, which is denoted by the symbol P, and potassium, which is denoted by the symbol K. These three are the primary plant nutrients that plants need to take up in large quantities in order to survive. Nitrogen and phosphorus in particular can also be problematic in the environment. So those are the two that we're going to really focus on. When we think of the soil, we often think of it as acting kind of like a sponge. It can soak up and hold on to nutrients, but there becomes a critical level in the soil where these nutrients can become lost because the soil just can't hold on to them anymore. Similarly here, we demonstrate how a sponge can hold on to water, but only so much. As we add water, it slowly soaks into all the little cracks and crevices within the sponge, but as those fill up, eventually they kind of overflow and the water starts leaking from the sponge. That's very similar to what happens with nutrients, especially something like phosphorus. The soil can really hold on to it, but it can get to the point where it can't hold on to anymore. So overall, land application of compost is really a balancing act. You want to make sure you have enough nutrients for your crops, but not too many nutrients so that we don't have these environmental issues. Compost is a really great source of nutrients, but it is different than raw manure. Raw manure is going to have a lot more first-year available nutrients than finished compost. The composting process actually kind of locks away the nutrients and turns them into more of a slow release source. And there's also differences between NP and K and their final concentrations left after the composting process as well. For instance, say you have a certain amount of NP and K in your raw manure. Through the composting process, some of the nitrogen can be lost through the gaseous components. Some estimates are up to 50% of the nitrogen can be lost, and typically the P and K remain. They don't usually get lost through the composting system. But one thing you'll notice is that the volume of the manure and then the finished compost are different as well. So while you have the same units of P and K in your finished compost, it's going to actually look like a higher concentration because technically there is less material but the same amount of P and K. So it actually would look like your P and K increased over the composting process while your nitrogen tends to decrease. Now, these are true for composting systems that are in arid regions where there's not a lot of rainfall, or if you have covered composting systems. In cases where you get a lot of rainfall, the rainfall can actually go through the pile and carry the NP and K out of it as well. So that's one influencing factor of the weather and how that will impact your final nutrient contents of your compost as well. The next question is, does it really matter how much NP and K there is? And again, yes. It turns out that plants need different ratios of these different nutrients. It's a rule of thumb that there's roughly 6 units of nitrogen taken up for every 1 unit of phosphorus. And this, of course, can change depending on what crop you're growing, when you harvest it, that sort of thing. But this is kind of a good rule of thumb. So if we go back to our unit of compost, say it's 1 ton of compost, and say that it roughly has 1 unit of nitrogen to 1 unit of phosphorus to 1 unit of potassium. So you can see based on how many units are in the compost versus how many units need to be taken up by the corn crop in this example. To meet the nitrogen needs, you're gonna have to add a fair amount of compost. In this case, let's say we're gonna add 6 tons of compost. That will get us our 6 nitrogen units that we need. And it gets us our 1 phosphorus unit, but it also adds an additional 5 units of phosphorus to the soil. And this can be problematic because we often find that phosphorus and even potassium can build up in the soils over time if you're frequently applying things like compost. So if we want to think about it as just a good phosphorus source, perhaps, go back to adding our 1 unit of phosphorus, and that also accounts for 1 unit of nitrogen, but you are going to need to add 5 more units of nitrogen with commercial fertilizers. So that's the one thing about whether it's raw manure or compost, any of these organic materials that you might add for a nutrient source often have to be balanced in one way or the other by fertilizers. Now, one thing to consider, however, is how often you're going to apply this composted material. If it's once every couple of years, you might not have to worry about the phosphorus buildup in the soil as long as you're not adding any more phosphorus through fertilizers, because the crops over those few years will slowly take up that phosphorus and be removed during harvest. On the other hand, if you are applying compost often, maybe every year or so, then you definitely want to watch your soil test phosphorus levels, because those are going to help you know if your soil phosphorus levels are building up. So as we've discussed, compost has a low availability of nitrogen. So because of that, we recommend using a phosphorus-based rate. And then you can kind of adjust it if your soil test levels are already high for phosphorus. Maybe you want to use a lower application rate. And then if you have really low soil test phosphorus levels and want to build your phosphorus up a little, you could potentially tweak it to be a little bit of a higher rate. Big thing to remember though is to credit the nitrogen that's applied. And if you do want to apply a nitrogen-based rate, never apply more compost than meets the end needs. So when we're calculating our application rates, let's go ahead and assume that you're going to apply the compost based on the phosphorus needs of the crop instead of the nitrogen needs. So we'll go through 3 steps. First, you need to determine how much phosphorus will be needed by your crop. With this, you'll need to know what crop are you growing, what yield you expect to get from that crop, and from there you can determine how much phosphorus you might need to apply. The second step is to determine the plant available P content of the compost. Generally speaking, we think it's similar to what a raw manure might be, although under certain circumstances it might be a little less. But roughly 80% of the total phosphorus in the compost should be available that first year. And then from there, you can calculate your rate of application for the last step. All right, so let's get into the details. Step 1, determine your phosphorus needs of the crop. In this case, we're going to use the P removal rates. Let's walk through an example. Say you want to apply compost to a field that will be seeded into alfalfa the next year. Here is a table or 2 tables of crop removal rates. You'll notice the crop is listed on the left side of each of these tables. Yield units, so what yield we might be talking about, is in the middle of each table. And then the amount of P2O5 removed in pounds. Now P2O5 is considered a form of phosphorus, but realistically it's not actually something that plants take up. But a long time ago, some folks in the fertilizer industry decided that's how they're going to label fertilizer bags. And that has continued until today. So to be able to compare apples to apples when we're talking about composted manure versus fertilizer, we're going to still use those units. So if you remember back to our example, we're going to apply the composted manure to an alfalfa field before planting it. And we expect to get 5 tons per acre in that year for the yield. So 5 tons per acre, and we can see that we removed 10.8 pounds of P2O5 per ton. And 5 times 10.8 equals 54 pounds per acre of P2O5 needed. So that is the application rate that you'll need to apply the compost at. Moving on to step 2, we have to determine the amount of available phosphorus that we'll get in the first year from the composted manure. And as mentioned, we assume that 80% of total P in the compost is available the first year. So what you need here is your compost analysis, and I believe Chrissy's talked about that previously. So from there, you'll find a total p-value, and usually in the Midwestern United States region, your analysis will report phosphorus as P2O5, but if it's not, you'll need to convert it to P2O5. Multiply this value by 0.8, because that refers to the 80% availability, and from there you get your PAP, your plant available phosphorus. So in our example, let's say our composted manure has 5 pounds of P2O5 per ton. Multiply that by our availability factor of 0.8, and we get 4 pounds of P2O5 per ton. So step 3 is to divide step 1 from step 2. So you have your net P recommendation from step 1, divide it by the plant available P in the compost from step 2, and that will equal your P-based application rate. So in our example, if you remember, we needed to apply about 54 pounds of P2O5 per acre for our alfalfa. And in the compost, we have about 4 pounds of P2O5 per ton available. And there we get our answer, 13.5 tons per acre. So how much nitrogen was added then? It's very important to make sure you're crediting all of the nitrogen that might be added from your various different sources, and that includes if you apply compost. So in this case, there's not a high availability of nitrogen from composted materials. We assume that about 10 to 15% of the total N in the compost is available the first year. And generally speaking, we use the lower end for cattle, sheep, goats, etc., the 10% for that. And we do use a bit of a higher range for composted poultry manure. Since that has a really high starting value of nitrogen, it tends to have a little higher availability in the finished product as well. So overall, you have your total nitrogen content of your compost. You can get that from your compost analysis. Multiply it by the availability factor. Then you multiply that by the amount that was applied, which we figured out how much you were going to apply based on the phosphorus levels. And you get your nitrogen first year credit from that. So let's look at our example. Say that our total nitrogen content was similar to our total phosphorus content, about 5 pounds of total N per ton. The availability factor, we're going to use the lower amount, so 0.1, which is about 10%. And we applied 13.5 tons. So multiply all these together and you get about 6.75 pounds of N per acre. I'd probably round that up to about 7. So that would be the credit from the compost in that first year. Once you take both of those into consideration, you can continue on and do the rest of your nutrient management planning for your crops. That's all I have for you today. Thank you so much, and look for further resources on the website for manure composting. Thanks.